The National Electrical Code, or NEC, serves as the official rulebook for electrical installations within the United States. Its website is nfpa.org/NEC. The Electrical Engineering Portal, or e-Portal, is a comprehensive website providing articles, guides, and tutorials covering all facets of electrical engineering. Its website is eportal.com. All About Circuits is dedicated to electrical theory, offering tutorials and videos. Its website is allaboutcircuits.com. Khan Academy provides free online courses and videos encompassing a broad spectrum of subjects, including electricity, at Khan Academy. org/science/physics/circuits. Consider these books: Electrical Theory and Applications by Stephen L. Herman, The Complete Idiot's Guide to Electrical Wiring by John Traister, Electricity for Beginners by Jonathan Adams, and Residential Wiring by Gary Rockies. Apprenticeship programs offer formal opportunities, blending classroom instruction with practical on-the-job training. Investigate options through your local electrical union or trade school. Community colleges commonly offer certificate or associate's degree programs in electrical technology. Online courses are available from some universities and colleges for studying electrical theory. The Electrical Contractors Association, or ECA, offers training and resources for electrical contractors with its website at ecassociation.org. The National Electrical Contractors Association, or NECA, represents the electrical contracting industry and provides training programs accessible at NECA.org. The American National Standards Institute, or ANSI, publishes electrical standards and guidelines available at ANSI.org/standards. To effectively integrate electrical knowledge, firstly, establish a firm grasp of fundamental electrical principles such as voltage, current, resistance, and power. Secondly, engage in hands-on electrical projects. Construct circuits and assess electrical components to gain practical experience. Thirdly, consider joining a study group or attending workshops. Collaborating with peers or professionals facilitates clarification of concepts and enables learning from others' experiences. Fourthly, incorporate visual aids. Diagrams, charts, and videos can aid in visualizing electrical principles and connections. Fifthly, maintain organization. Utilize a notebook or binder to systematically record notes, calculations, and project plans. Understanding voltage is crucial. Voltage is the electric potential difference between 2 points in a circuit measured in volts. It's the push that drives electric current through a circuit. Think of it as the pressure in a water pipe. The higher the pressure, the more water flows. Similarly, the higher the voltage, the more current flows through a circuit, assuming the resistance stays the same. You can measure voltage using a voltmeter, connecting it in parallel across the component you want to measure the voltage drop across. The standard unit of voltage is the volt, often abbreviated as volts. Common voltage levels you'll encounter include 120 volts in residential outlets, 208 volts and 240 volts in larger appliances in some commercial settings, and higher voltages like 277 volts and 480 volts in industrial applications. Always be aware of the voltage levels you are working with, as higher voltages can be dangerous. Current is the flow of electric charge through a circuit, measured in amps. It's the rate at which electrons are flowing. If voltage is the pressure in a water pipe, current is the amount of water flowing per unit of time. You can measure current using an ammeter, connecting it in series with the circuit you want to measure the current in. Be careful when measuring current, as you can easily overload an ammeter if you are not sure what the current level is. The standard unit of current is the amp, often abbreviated as amps. Common current levels you'll encounter depend on the specific circuit and load, but you'll often see currents ranging from milliamps in small electronic circuits to hundreds or even thousands of amps in high-power industrial applications. Resistance is the opposition to the flow of electric current in a circuit measured in ohms. It's like a constriction in a water pipe that limits the flow of water. The higher the resistance, the less current flows for a given voltage. You can measure resistance using an ohm meter, but you must disconnect the component from the circuit first. The standard unit of resistance is the ohm, often represented by the Greek letter omega, ohms. Common resistance values range from fractions of an ohm in conductors to millions of ohms in insulators. Power is the rate at which electrical energy is transferred or used in a circuit measured in watts. It's the product of voltage and current. If voltage is the pressure and current is the flow rate, power is how much work the water can do. The higher the voltage and current, the more power is delivered. Power is calculated using the formula power equals voltage times current, or P equals VI. The standard unit of power is the watt. Common power levels range from milliwatts in small electronic circuits to kilowatts or megawatts in large electrical systems. Electrical circuits can be either series or parallel. In a series circuit, components are connected end to end, so the same current flows through all components. The total resistance in a series circuit is the sum of the individual resistances. If one component fails in a series circuit, the entire circuit is broken and no current flows. In a parallel circuit, components are connected side by side, so the voltage is the same across all components. The total current in a parallel circuit is the sum of the individual currents. If one component fails in a parallel circuit, the other components continue to function. Ohm's law is a fundamental law of electrical circuits that relates voltage, current, and resistance. It states that voltage equals current times resistance, or V equals R. This law can be used to calculate any of these three quantities if you know the other two. For example, if you know the voltage and resistance in a circuit, you can calculate the current. Or if you know the current and resistance, you can calculate the voltage. Kirchhoff's current law, or KCL, states that the total current entering a junction or node in a circuit must equal the total current leaving the junction. This is based on the principle of conservation of charge. In other words, charge cannot be created or destroyed at a junction, so the amount of charge entering must equal the amount of charge leaving. Kirchhoff's voltage law, or KVL, states that the sum of the voltage drops around any closed loop in a circuit must equal zero. This is based on the principle of conservation of energy. In other words, energy cannot be created or destroyed in a closed loop, so the sum of the voltage gains must equal the sum of the voltage drops. Understanding how to use a multimeter is essential. A multimeter is a versatile tool that can measure voltage, current, and resistance. To measure voltage, set the multimeter to the volts setting and connect the probes in parallel with the component you want to measure the voltage across. To measure current, set the multimeter to the amp setting and connect the probes in series with the circuit you want to measure the current in. To measure resistance, set the multimeter to the ohm setting and disconnect the component from the circuit before connecting the probes across it. When working with electrical circuits, it's important to follow safety precautions to avoid electric shock or other hazards. Always turn off the power before working on any circuit. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. Never work on live circuits unless you are properly trained and equipped to do so. Follow all applicable electrical codes and regulations. Grounding is an important safety measure that provides a low resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electric shock. Grounding systems typically involve connecting the metal enclosures of electrical equipment and appliances to a grounding electrode, such as a ground rod or water pipe. Bonding is another important safety measure that involves connecting all metal parts of an electrical system together to create a low impedance path for fault current. This helps to ensure that all metal parts are at the same potential, reducing the risk of electric shock. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds a certain level, while fuses are one-time devices that melt and break the circuit. It's important to choose the correct size circuit breaker or fuse for the circuit to protect it from damage. National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years and is widely adopted by state and local jurisdictions. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Understanding the NEC is essential for any electrician or electrical contractor. There are several common wiring methods used in electrical installations, including non-metallic sheet cable, or ROMIX, flexible metal conduit, or FMC, and rigid metal conduit, or RMC. Non-metallic sheet cable is commonly used in residential wiring, while flexible metal conduit and rigid metal conduit are often used in commercial and industrial applications. Each wiring method has its own advantages and disadvantages, and the choice of wiring method depends on the specific application. Box fill calculations are used to determine the maximum number of conductors that can be safely installed in an electrical box. The NEC specifies the minimum size of electrical boxes based on the number and size of conductors they contain. It's important to follow box fill calculations to prevent overheating and other hazards. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC specifies the maximum allowable voltage drop for different types of circuits. It's important to calculate voltage drop to ensure that the voltage at the load is within acceptable limits. Short circuit current is the high current that flows in a circuit during a short circuit. Short circuit currents can be very high and can cause significant damage to equipment and wiring. It's important to calculate short circuit current to properly size overcurrent protection devices. Ground fault circuit interrupters, or GFCIs, are devices that protect people from electric shock by detecting ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. GFCIs quickly interrupt the circuit when a ground fault is detected, preventing electric shock. Arc fault circuit interrupters, or RFCIs, are devices that protect against fires caused by arc faults. An arc fault is an unintentional electrical discharge that can occur when insulation is damaged or worn. RFCIs detect arc faults and interrupt the circuit, preventing fires. Electrical drawings and blueprints are used to represent electrical systems and components. These drawings typically include symbols for different types of equipment and wiring, as well as information about circuit layouts and wiring schedules. Understanding electrical drawings is essential for installing and maintaining electrical systems. Electrical codes and standards are constantly evolving to keep up with new technologies and safety concerns. It's important to stay up to date on the latest codes and standards to ensure that electrical installations are safe and compliant. Firstly, familiarize yourself with Article 90 of the National Electrical Code, or NEC, which provides an introduction to the code and outlines its scope, purpose, and enforcement. Secondly, study Chapter 1, which covers general requirements for electrical installations, including wiring methods, overcurrent protection, and grounding. Thirdly, focus on Chapter 2, which deals with wiring and protection, providing detailed requirements for conductor sizing, overcurrent protection, and grounding. Fourthly, delve into Chapter 3, which covers wiring methods and materials, including specific requirements for different types of wiring and cables. Fifthly, explore Chapter 4, which addresses equipment for general use, providing requirements for electrical boxes, switches, receptacles, and lighting fixtures. Sixthly, examine Chapter 5, which covers special occupancies such as hazardous locations, healthcare facilities, and swimming pools, with specific requirements for these environments. Seventhly, study Chapter 6, which deals with special equipment, including requirements for electrical signs, electric welders, and elevators. Eighthly, analyze Chapter 7, which covers special conditions such as emergency systems, standby power systems, and fire alarm systems. Ninthly, investigate Chapter 8, which focuses on communication systems, including requirements for telephone, data, and cable television wiring. Tenthly, familiarize yourself with Chapter 9, which provides tables and examples for calculating conductor sizes, conduit fill, and other electrical parameters. Single-phase power refers to an alternating current, or AC, electrical power system where the voltage varies in a single cycle. It is commonly used in residential and light commercial applications to power lighting, appliances, and small motors. Single-phase systems typically use 2 or 3 wires, a hot wire carrying the current, a neutral wire providing a return path, and sometimes a ground wire for safety. Three-phase power is an AC electrical power system where the voltage varies in 3 cycles, each offset by 120 electrical degrees. It is widely used in industrial and commercial applications to power large motors, HVAC systems, and heavy equipment. Three-phase systems provide more power and efficiency compared to single-phase systems and typically use 3 or 4 wires. 3 hot wires carrying the current and sometimes a neutral wire for unbalanced loads. Transformers are electrical devices used to transfer electrical energy between circuits through electromagnetic induction. They consist of 2 or more coils of wire wound around a common core. Transformers can be step-up transformers, increasing voltage and decreasing current, or step-down transformers, decreasing voltage and increasing current. They are essential components in electrical power distribution systems for adjusting voltage levels to match different equipment and applications. Motors convert electrical energy into mechanical energy. They use electromagnetic fields to produce rotational force, or torque, which can be used to drive various types of machinery and equipment. There are different types of motors, including AC motors, such as induction motors and synchronous motors, and DC motors, such as series motors, shunt motors, and permanent magnet motors. Each type of motor has its own characteristics and is suitable for different applications. Motor control circuits are used to start, stop, control the speed, and protect electric motors. They typically consist of a combination of components such as switches, relays, contactors, motor starters, and overload relays. Motor control circuits can be simple manual control circuits or more complex automatic control circuits with advanced features such as variable frequency drives and programmable logic controllers. Lighting systems provide illumination for various spaces and activities. They consist of light sources, such as incandescent lamps, fluorescent lamps, light-emitting diodes, or LEDs, and lighting fixtures that hold and distribute the light. Lighting systems are designed to provide adequate illumination levels, reduce glare, and improve visibility and safety. Different types of lighting systems are used for different applications, such as general lighting, task lighting, accent lighting, and emergency lighting. Panel boards are electrical distribution devices that receive power from a source, such as a transformer or service entrance, and distribute it to various branch circuits. They typically consist of a metal enclosure containing circuit breakers or fuses that protect each branch circuit from overloads and short circuits. Panel boards are used in residential, commercial, and industrial buildings to provide a safe and convenient way to distribute electrical power. Raceway systems are used to protect and support electrical conductors. They include conduits, tubing, cable trays, and other types of enclosures. Raceway systems provide a physical barrier to protect conductors from damage, moisture, and other environmental factors. They also provide a safe and organized way to route conductors throughout a building or facility. Grounding and bonding are essential safety practices that help to protect people and equipment from electrical shock and damage. Grounding provides a low-resistance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electric shock. Bonding connects all metal parts of an electrical system together to create a low-impedance path for fault current, reducing the risk of electric shock. Electrical safety is paramount when working with electricity. Firstly, always de-energize circuits before working on them. Use appropriate lockout/tagout procedures to ensure that circuits are not accidentally energized while you are working on them. Secondly, use insulated tools and personal protective equipment, such as safety glasses and gloves, to protect yourself from electrical shock and burns. Thirdly, never work on live circuits unless you are properly trained and equipped to do so. Always follow safe work practices and procedures to minimize the risk of electrical hazards. Electrical testing and troubleshooting are essential skills for electricians and electrical technicians. Firstly, use a multimeter to measure voltage, current, and resistance in electrical circuits to identify problems. Secondly, use a circuit tracer to locate conductors and identify wiring errors. Thirdly, use an insulation tester to check the insulation resistance of conductors and equipment. Follow safe testing procedures and use appropriate personal protective equipment when performing electrical testing and troubleshooting. Be aware that a short circuit is an abnormal condition in an electrical circuit where current flows through an unintended path with very low resistance. This can be caused by damaged insulation, loose connections, or other faults. Short circuits can cause excessive current flow, overheating, and damage to equipment and wiring. Overloads occur when the current in a circuit exceeds the rated capacity of the conductors or equipment. This can be caused by excessive loads such as too many appliances plugged into a circuit or by malfunctioning equipment. Overloads can cause overheating, damage to equipment and wiring, and can potentially lead to fires. Ground faults occur when current flows through an unintended path to ground, such as through a person's body or through a metal enclosure. Ground faults can be caused by damaged insulation, moisture, or other factors. Ground faults can cause electric shock and can be very dangerous. Electrical codes and standards are constantly evolving to keep up with new technologies and safety concerns. Stay up to date on the latest codes and standards by attending training courses, reading industry publications, and participating in professional organizations. The National Electrical Code, or NEC, is a comprehensive set of standards for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years and is widely adopted by state and local jurisdictions. Article 90.3 of the NEC outlines the examination of equipment for safety. Equipment that complies with the provisions of the NEC is not necessarily acceptable if approved. Installers are responsible for ensuring equipment is suitable for its intended use. Article 110.3 B covers installation and use. Listed or labeled equipment must be installed and used in accordance with any instructions included in the listing or labeling. Article 110.12 addresses neat and workmanlike manner. Electrical work must be installed in a neat and workmanlike manner. This includes proper routing and support of conductors, proper termination of connections, and proper labeling of equipment. Article 210.12 provides requirements for arc fault circuit interrupter protection. Arc fault circuit interrupters, or RFCs, are required in many residential circuits to protect against fires caused by arc faults. Article 250 provides requirements for grounding and bonding. Grounding and bonding are essential for electrical safety and help to protect people and equipment from electric shock and damage. Article 300.11 covers securing and supporting wiring methods. Wiring methods must be securely fastened and supported to prevent damage and ensure proper operation. Table 310.16 or 310.15 B16 provides ampacity ratings for conductors. The ampacity of a conductor is the maximum current it can carry safely without overheating. It is important to select conductors with adequate ampacity for the intended application. Article 408 provides requirements for switchboards and panel boards. Switchboards and panel boards must be installed in a safe and accessible location and must be properly grounded and protected from overcurrent. The NEC is not a design manual. It provides minimum requirements for electrical safety. Electrical designers and installers must use their professional judgment and experience to ensure that electrical systems are safe and reliable. In addition to the NEC, there are other electrical codes and standards that may be applicable to specific installations. These include state and local electrical codes, as well as industry standards such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. Continuous learning is essential for electricians and electrical technicians. The electrical industry is constantly evolving, and it is important to stay up to date on the latest technologies, codes, and standards. This can be achieved through formal training courses, on-the-job training, and self-study.